So prior to the construction of the new Santa Rita water reclamation facility, the previous plant had a real problem with organic loading. We were seeing high E. coli in the effluent, so much so that it was making it further downstream and becoming a real issue for other users of the Animas River. And since we've done the upgrades on the treatment plant, we're seeing E. coli less than 10 mpn. We're seeing extremely low numbers in our total inorganic nitrogen and total phosphorus as well. And we're not hearing as much concern from downstream users of the Animas River.
So when we were laying out this facility, odors were a really big deal. As you can imagine, because we have the world-class kayaking park adjacent to us, the Animas River Trail, a soccer park, the major highway coming to the city is right adjacent to the facility. Odors were a major big deal at this facility. We had to minimize it. So we went through and identified the major odor generating areas. And for all those areas, we tried to put in 1 or 2 technologies each location to make sure we could either contain it, ventilate, and treat that technology at every place. So the headworks, we're both treating the foul air and we're treating all the air that comes in. Off the primary clarifiers, we collect all that odor generating air and send it through a GAC system to remove all the odorous compounds to make sure they don't migrate outside. The primary clarifiers were a primary odor source for the old facility. Another requirement the city wanted is their city is very environmentally friendly and green and wanted to minimize power requirements, energy requirements at this facility. So when we were designing this facility and laying it out, we tried to minimize all the power requirements and do everything we could to maintain the best treatment at the lowest power input. So when we looked at designing the secondary process, we came in and fractionated the influent BOD, COD to make sure we had the right requirements necessary to do all the treatment we needed. So we have this custom designed Johannesburg process that gives the operators the flexibility they need to control various different knobs and buttons to help meet their current effluent requirements, while giving them tools to tweak things should they need to change things midday, midweek to help them meet and maintain those limits. We put in energy efficient high-speed turbo blowers. We designed a very energy efficient air diffusion system that operates at the low end of the flux curves to minimize or maximize oxygen transfer while minimizing power. Additionally, we have primary clarifiers where we collect influent raw wastewater or raw sewage, send it to the anaerobic digesters along with our waste product to produce methane. We clean that biogas, scrub it with all the H2S and siloxanes, and then use it to produce methane. With that methane, we are able to produce as much power as about 40% of the total plant's power needs right here in the facility, despite the fact that this is only a smaller facility. And additionally, with that power generation, we also collect heat off that process and use it to preheat our digesters, therefore cutting back natural gas usage somewhere in the order of roughly 30%, all in an effort to make this facility as energy efficient as possible and make it as green as possible for the city so it could be a showcase for them.
So the end product of our construction was we met our nutrient standard regulations on day 1 of receiving our new permit. And that was a very exciting thing because it was kind of the culmination of a lot of effort, a lot of forethought, a lot of planning that frankly started before I even got here. And I was able to see that, the day we got that permit from CDPHE, we were actually exceeding those nutrient regulations in our effluent.